Well, hello everyone, and welcome back to Adrian's Digital Basement. This is part 2 in the BBC Master 128 series. Yes, it's going to be a series, I guess. If you haven't seen part 1, I recommend you watch that first, then come back to this video, which will be a continuation of where we left off in the first part. In this video, I'm going to give this computer a full detail, a full deep cleaning, and then try to refurbish this keyboard and actually use it and type commands on this thing, because even just typing in the CMOS setup stuff required after the battery dies on this computer wasn't possible due to all the non-working switches. So without further ado, let's get right to it. So the BBC Master 128. From part 1, it seems like the computer is working except for the keyboard, which has a lot of keys that aren't working properly. We'll talk about that more in a second, but I want to first start by giving this case a good cleaning. The outside is pretty clean, but the inside's pretty dirty. It looks like stuff was spilled in there, and the motherboard itself, while it doesn't have any corrosion on it, also has some gunk on it, which I want to get cleaned off. Then I will focus on this keyboard. In preparation for the case cleaning, I took out this little template, which was inside this little clear piece of plastic here. And it turns out that there were actually 2 little templates in there. And the interesting thing is this one that was hidden behind this black one says microfax. Now, when you see the word microfax, you might be thinking fax machine, as in facsimile, sending documents over the telephone line, but I don't think that's what this is at all. I think this software was something to do with the creation of CFax data. CFax was a system in use in the UK and maybe other countries as well that transmitted data and images over the television signal, over broadcast television. I think CFax was a name that the BBC used for their transmission of the data. I think it was called teletext pretty much everywhere else in the world that used PAL television systems. As far as I'm aware, teletext never made its way to the US, or maybe it did in just some tiny little test markets, but never gained any traction here. But certainly in the rest of the world, teletext services were pretty awesome. And I remember traveling overseas and like turning that on and scrolling through all the pages of text, and you could like see interactive response stuff where people were like sending messages and I don't know, all sorts of cool stuff like that, weather and stocks and things like that. I know the BBC Micro line of computers, including the Master, has the ability to display teletext. It has a particular chip in here that allows that. And I think it was pretty common for these systems to be used in the creation of that system as well, as in like the creation of the data that would then stream out to televisions. If you're familiar with the whole microfax software that maybe was used on this machine at some point, definitely put a comment in the comment section below. It looks like the other template that was on here though has more to do with editing. And I don't know if this is just like inside BASIC itself or maybe some of the built-in software that's available on the Master. Either way, I'm going to preserve both of these by removing them from the computer, which is why I took them out of here, because obviously when I go to wash the case, this paper will get damaged if I leave that in there. Now, looking inside the machine, I'm going to remove the keyboard because I'm going to work on cleaning that separately. Obviously, I'm not going to wash the power supply because I've already serviced that and I know that works well. We'll lift out this little plastic holder here, and I've also taken out that extra switch that went to the back of the case here for disabling and re-enabling the speaker. So I just soldered that wire back together. We'll remove the power supply, which I never reinstalled fully back in the case. And it looks like for the motherboard to be removed, you have to take these screws out around the cartridge connectors. I think those go, put those in the mugs. I think those go down into the bottom case. Now, potentially this lifts right out, and it does. There it is. This motherboard is in pretty good shape though. This is the gunk right here on the motherboard, which I think maybe leaked down from the original battery. Now, I didn't mention this in part 1, but this little plastic piece that sits here on the motherboard holds the speaker and aligns the cartridges, but it also holds the original clock battery or CMOS battery right here. And there is a little hole there and there, which means any kind of leakage from those batteries would find their way right onto the motherboard. But obviously this machine had this other battery here, which is a crusty, gross thing. Apparently this has a diode and a resistor in here, which looks like it's right there, because I think this machine normally tries to charge up the battery, and obviously this is not rechargeable. So to replace this, it's pretty easy. You just have to make sure you replicate the diode and the resistor there. But I would just be careful about installing it anywhere where that could leak in the future. And my thought is, since I have gone ahead and disabled this little toggle switch for the speaker, maybe I will set this up to be connected to the battery so that if I do have a battery in here and I leave it like a coin cell, for instance, then I can turn this off and it will keep that battery from draining when I'm not using this computer. And yes, it will lose all of its CMOS settings, but you just set those up again when you first power it up once you reconnect the battery. Looking at the motherboard here, this is the RAM. In case you were wondering, that's the 128K of RAM. These are 4464 chips. So each one is 64K by 4 bits. So 2 of them is 64K, and then that's 128K. Very similar to what's on use on the later Apple IIe's and the Apple IIgs and stuff uses those types of chips. Looking at the back of the board, it all looks pretty good. I do see some rework has been done right there on the board. There's a little baud resistor there. Let's see what that IC is. That looks like it's been swapped out, which without looking at schematics, I couldn't tell you what this is. VC2069. Looking inside the bottom cover, looks like we have a sticker here, made by operator number 1209, serial number 822024. Back here in the corner, it's pretty crusty, as well as right here. Definitely looks like something got spilled in the case, and then down here where the battery was, that definitely made a little bit of a mess. Rest of the case is pretty good, just a little bit dusty, but no big deal. Now I'm up here in the kitchen where I'm going to do some cleaning, and I don't normally show this, but recently I've done some cleaning and people have asked me, hey, can you show a little bit more of the process you use? Well, I'm gonna do just that. Basically, I go to the sink and I just use soapy water and clean everything. That's all there is to it. I put some soap and I use a little toothbrush. Oh, look at that. That is quite dark there. And I just scrub everything. And when it comes to labels like that, I don't really worry too much about it. I just try to, not rub them too much, and we'll get everything nice and cleaned up. I always find it very satisfying to watch the cleaning process. Even though I don't normally show this, I get to see it firsthand whenever I do it. And it is always amazing to me how filthy the water becomes in the sink after I've given a machine a good scrubbing. And the dirt really doesn't hurt anything to be inside the case or on a motherboard or whatnot, but nonetheless, it's still satisfying to see those things look clean and like they were new again. In case you're wondering why there are weird angled bars on the sides of the image, it's because I had the camera sitting up on a tripod on the countertop, and in post-processing here, I rotated the image so that it would look a little bit more like my perspective of washing the case here. And now the part of the video people are probably going to be shocked by. I'm going to wash the motherboard, and I start by just dunking it completely in the soapy warm water. I've cleaned numerous motherboards and cards this way, and I never have a problem. In fact, quite often when PCBs are manufactured, they are washed thoroughly afterwards to get all the flux residue and anything else from manufacturing off the board. So this water bath is not that unusual. We're really lucky in Portland, Oregon here to have municipal water that's very soft. It doesn't leave any mineral deposits behind, so I'm not so concerned about any kind of deposits forming after the washing. Even if you have hard water, all you need to do is rinse your parts with deionized water when you're done, or some alcohol, and then blow off all of the excess water before you allow it to air dry. Here, I'm using an ESD safe blower that a viewer sent in for a mail call episode many years ago. I absolutely love this thing, and I use it all the time. It does a great job at getting the water out from underneath chips and inside components and connectors. And as you can see, I'm using it on the outside of the case as well. It just really speeds up the overall drying process. Alrighty, so after washing and drying and a little bit of touch-up work with a Windex and a cloth, the top cover, it's looking really good. In fact, down in here, look how nice that looks. So much better. Luckily, none of the labels came off on the inside of the case. These are all still here, even though I fully washed it. Now you can notice that there's definitely some yellowing on this case, especially on the sides here, not so much in the middle. I'm not really too sure about retrobiting this case. Like, what will happen? Will it get splotchy? I want to try to avoid that. So I think I'm just going to leave it as is. I am going to try to clean up some of these little marks on the top cover though. So let's just see if I can rub one of these away just with the microfiber cloth. That actually seems to work. So I don't even need to use something more harsh. Sometimes the abrasion of the microfiber cloth is all you need to get rid of scuff marks like this. I try to avoid using magic eraser on textured plastic if I can help it, because it does sort of start to remove the texture and you end up with shiny spots, which kind of bothers me as well, almost more than the scuff does. So if you can get away with a microfiber cloth and a little bit of Windex or something else for cleaning, I would recommend doing that first. Just cleaning around the bezel of the keyboard. Look how dark the cloth is there. So that was getting off a good amount of gunk as well. On the bottom of the case, things look really good and the labels are all okay. I'm just gonna leave all of that stuff on there since that's sort of like a, I don't know, let's call it a patina for the case. I just wanted the top side to look a little less grimy, which I think is exactly how it looks now. The motherboard here looks pretty much as good as new. Some of the little stickers did flip up a little bit, and one of them came off as well. I think it was the serial number sticker right here, but I saved it so I can just glue it back on with a little, I don't know, glue stick or something like that. All of that corrosion that had dripped down in this area here is completely gone, which is fantastic. And even though I blew off as much of the water as possible, like from under the chips and everything with that air duster, I'm still gonna let this thing sit for several days just to make sure that it is fully dry before I power it up. Although honestly, a tiny little bit of water on the motherboard, it doesn't really cause a problem because we're talking about 5 volts, very low voltage. And now we begin the long process of trying to refurbish this keyboard. First step is to take a photograph of it so you can reinstall all the keys back in their original locations. As you can see, as I remove these keys, there's a good amount of corrosion underneath the keycaps on the base plate. And this is actual corrosion that isn't just filth and dirt, although there's a lot of that as well. On this particular keyboard, the only thing that's stabilized is the space bar, and you have to be very careful removing it that you don't break anything. And there are 2 little stabilizer parts that plug into the bottom of the space bar and connect up to the stabilizer bar that's underneath the base plate. Next up, I'm going to use a vacuum cleaner to just try to clean up as much grime and dust from the top side of the keyboard. So I'm using a bristle brush and just sucking it all up. I'm using some Windex just to try to get the last little bit of grime off, and I'm not being very successful. Next up, I want to try to see about these key switches. So hooking up the multimeter to a particular switch allows me to work on that one switch and test for any kind of fixes that I want to try to apply to it. I read online all sorts of different solutions, like pushing the key 1,000,000 times or putting some deoxit inside. So the very first step is you want to get your multimeter hooked up in a reliable method so you can start doing that testing. So when you hook up the multimeter with continuity checker, you should see close to 0 ohms when you push one of the key switches. And if you're not, well, that's going to be a problem. So I'm pushing it 1,000,000 times trying to see if I can get it working. And I'm really not having much luck. I tried putting deoxit in there and pushing it another 1,000,000 times, and that didn't work either. I tried some alcohol in there, 99% IPA. That didn't really help. I tried some contact cleaner as well, CRC contact cleaner, and that didn't really help. Didn't really seem like anything was really working that well. Although I have to say, it did sort of start to work after many, many pushes. So now I'm moving over to the other enter key, the main enter key on the keyboard, because that one was also not working. And I'm going to try seeing if I can get this key working by doing similar means. Problem is here is that this is a very time-consuming process, and I honestly don't believe this is necessarily going to be reliable in the long term. So if you have a large number of key switches that aren't working reliably like I do on this keyboard, I don't really think that this method is going to be particularly reliable for getting things working. Maybe if you have 1 or 2 bad key switches, you can try this out, but I can't imagine doing this over like the 20 or so key switches that I have that pretty much don't work reliably or just not working at all. So you can see here, I'm really struggling with this particular key switch. It does not want to come back to life. I'm always getting a very high resistance on it. So I've decided to take the nuclear option, and I'm putting the entire keyboard into the sonic cleaner. I have this large one I picked up, so it's up here in the kitchen, and it has some soapy water in there, and that's it. There's the whole keyboard in it. With the keyboard drying and out of the sonic cleaner, I focused on the keycaps. I put them in a jar with some water and some denture cleaner tablets. Yes, this stuff is effervescent and does a really good job at cleaning the grime off of keycaps. Once I rinse the caps off, I tip them out onto this sheet here, and I wipe each keycap to get any extra residual grime off them. Then I shake out any additional water from the bottom and lay them face up in this box here so that they can air dry over the next couple days and be fully ready for reinstallation into the keyboard. All right, so it has been a number of days since I washed this thing. Let's reveal the motherboard under there. Of course, I wanted to make sure that everything completely dried before I tried turning this on, but yeah, this motherboard, I mean, it was pretty clean already, but now it looks absolutely brand new. I'd say the only thing that kind of lets it down is the RF modulator here. It's not very shiny anymore, but take a look at how clean the case is. Oh, there's a little bit of dirt down there, but you know what? I'm not too fussed with that. I just wanted it to look a little less grungy. Now, what I haven't tested out is the keyboard at all. Let's get this plugged in. What I did to the keyboard after I was done with the sonic cleaner is I covered it with 99% IPA inside the switches as well, hopefully to help it dry out a little bit. Then I used the air blower to dry out or blow out as much water as possible. Then I put deoxit down every single switch, whether they were working or not, because I'd be honest, I didn't take an accurate map. And then I just pushed on all the switches many, many times. And then I just let it sit. So it's been several days. All I can hope is that deoxit had a positive effect. Now in the time-lapse video, when I was using the multimeter connected up directly to the switches, this enter key would just not work no matter what. This enter key was working after the deoxit and pushing it a whole bunch of times, but this one was not. I tested it the other day though, after this keyboard had been sitting a while, and that was with the multimeter on the back, and it appears to be working. It has like about 1 ohm of resistance when you push it. So my fingers are crossed. I can't really cross my fingers very well after my hand surgery, but my fingers are crossed. Come on, baby, that this keyboard is gonna work well. So at this point, it is now time to put this power supply back in the machine. And it goes like that. It goes under the motherboard little clip here because there's a screw that goes in there, but I think it goes on top of the keyboard like it is here. Because once the power supply is screwed into the case, there are screws on both sides, that helps hold the keyboard down. Whenever you do something like wash the motherboard like I did, there's always a chance, possibly, that something might have got damaged. And while I was scrubbing it and doing all that stuff to it, I've never personally had an issue, and I've washed many, many motherboards in the past, especially ones that are much dirtier than this. But let's just hope that the motherboard works, and then of course, that the keyboard works, because then I can put the keys back on and finally test this thing out. That'll be really cool. Incidentally, if you have a BBC Master and you're not very familiar with it, like me, I'm not familiar with it, I figured out that the composite video output, which is this one right here, actually is monochrome, doesn't have any color output. The RF output is in color, but of course I can't use that because I don't have any PAL TVs. Anyhow, I think I'm stalling here when it comes to testing this thing. So let's get the power cord unraveled here and plugged into the wall. And let's see how this computer is working. I'm hoping it will work. That'll be the best possible outcome here. Then I can finish reinstalling all the parts of the machine, putting it all back together, getting the keys on there, stuff like that. And then we'll build a battery to plug into this motherboard so that I can set the CMOS options, because they'll be lost, of course, every time I power it up now. Because I am looking forward to exploring this computer a little bit, playing around with it, getting to know how it works. And obviously without a working keyboard, as I said in the last video, that's not really possible. All right, enough stalling. I'm switching this over to composite. Here we go. Okay. Oh yes, okay, awesome. The computer appears to work. This is exactly where we were before. Oh, okay, 5 key is not working. Oh dear, 6 is not working. 8, 9, okay, how about enter now? Oh, enter does work. Okay, so how about this one? Okay, these 2 enter keys work. I spent a lot of time focusing on these 2 enter keys. I don't think you can really see that in the video, but this one here and this one here, I deoxit, push them a million times. The biggest issue here is when I talk to people about this machine, they said this keyboard generally is reliable, but if you have keys that don't work, you just push them a million times. Well, I mean, that's fine, but like, I don't know, but let's just see. Okay, so the 5 key doesn't work, and there is deoxit in that switch, although it's been in there for several days now. So let's just push this switch a whole bunch of times I put a keycap on here because it's just easier to push. People were like, push it 50 to 100 times and then it should start working. Oh, I don't know. This keyboard, as you can see here, it's been through a lot, right? It's got a lot of corrosion on it. When you have corrosion and key switches, those things they don't go well together. And in case you are wondering that there's a problem with the electronics or whatever, I don't think so, because I can easily just grab the multimeter here and test the switch on the back, and it's not making any connectivity. That's how both of these enter keys work. Now, I put 99% IPA in there, I put deoxit in there, I blew air in them. This is all without taking them apart. And of course, this whole thing has gone through the sonic cleaner. And I mean, we're getting absolutely nothing out of the 5 key here. 6 and 5, nothing at all. I'm gonna use this paper here to write down every switch that doesn't seem to be working. I can't test every one of them because I don't think like these F keys do anything when you're in this mode here, but I'm gonna see from the ones I can test which ones aren't working. And this is what I found. 5, 6, 9, R, S, all don't work at all. These keys, I crossed it out, but D, F, H, L, Z, or Z, V, B, N, those work, but very flakily. Like you have to push them a bunch of times and then you start getting letters. The period key doesn't work at all. Left shift and right shift both don't work at all. And then the number pad period key or decimal point, that works. I wrote an underline because that means it works kind of, like you have to push it a few times and it starts to work. But the number pad plus doesn't work at all. So we have 9 totally non-working keys, but then it is worrisome that there are this many that are flaky as well, because I worry that putting deoxit in them and they might work right now means that if I don't use the computer for say 6 months to go back to use it, all of those keys with the underline are gonna be not working again. Now going back to the 5 key, I pushed on it a whole bunch of times and it has just, nothing's happened. It does not come back to life. Now personally, I've never worked on a keyboard that has these switches. I think Futaba is the name of these switches. First time I've ever seen them. But I've worked on plenty of other mechanical boards with ALP switches and stuff like that, and I've really found that there's just no recovering them a lot of times. You can kind of get them working with deoxit, you know, spraying stuff like this in there or stuff like this in there, but they always end up kind of going bad again. And it makes using the computer really, really frustrating. It's one thing if it's like a Macintosh or an Amiga where you're doing a lot of mouse and joystick input, but on a computer like this where you're gonna be typing in basic programs, when you get like double key pushes or you get missed key pushes, it's really, really frustrating. Well, at this point, the only thing I can think of doing is taking off some of these non-working key switches and seeing if I can open them up and maybe do some kind of cleaning on the inside, see how difficult that is. Okay, so that wasn't nearly as hard as I thought. Take a look at the keyboard here. You'll notice there's a bunch of missing key switches over on the numeric keypad. Why is that, you ask? Well, I decided to just do the old swaparoo and take out the key switches that weren't working and replace them with the ones from the numeric keypad, which, except for the period key, or sorry, the plus key, which was this one up here, these were all working properly. Now on the first pass of swapping the key switches around, I did 5, 6, 9, R, S, and period, oh, and the left and right shift, and that fixed all those switches. Then I went through and tested all the keys again, and it turned out that U, H, B, N, and the period key, these keys were working, but kind of flaky. So I went and harvested more switches from this and stuck them in the main part of the keyboard. And I think everything is working on the main part of the keyboard. I don't know about the copy key and I don't know about the F keys, which are on the top row. I can't seem to test those, or I don't know how to use those keys, at least from basic, or not even in basic. I'm just in that like command prompt mode. So here we are and the computer's powered up, and what's really funny is I had to take some phone calls and I went and made dinner, and I actually left the computer on the whole time. I completely forgot that it was running. So this thing has been turned on for probably 4 hours now, and we can see that it's still working. So that's a good sign, like nothing failed on this thing, just sitting here running. So excellent, I guess. When I left this computer, all of the primary keys are now working. Strangely enough, a key that was working and it's not anymore is the enter key over here on the numeric keypad. Okay, well, it's decided to start working again. It didn't work the first time I just pushed it, but after I did the second swap of the keys, so I have it how it is here, yeah, the enter key wasn't working. Let me move the BBC Master out of the way and let's take a look at those key switches. Okay, so here's the Futaba switch. I think that's how you pronounce it. It goes into the base plate like this, with that little clip facing away from you. And it's funny because these are actually really, really easy to remove from the board. All you have to do is desolder the 2 pins on the backside. I use my Hakko desoldering pump. And then you just basically give it a little bit of a push from the backside on the PCB, and it actually just pops it right out of the base plate. So unlike ALP switches where you kind of have to struggle getting these little clips pushed in, you don't have to do that on these switches. Now you see the body is round, and I don't exactly know how to take these apart, although it seems like this clip at the top here has something to do with the switch assembly itself. And I feel like if I manage to bend that out, then maybe I could slide this apart somehow. Either way, we have the multimeter here in continuity mode, and let's test these quickly to see what's working and what's not working. All right, first switch here, nothing. Nothing at all. Okay, so I'm gonna make some different piles here. Here's what we got. These switches here are totally dead, not working at all. These switches are kind of working. They're flaky, but they work. And then this switch, this one appears to be working normally. So the question is what do I do exactly? People have mentioned that it is possible to take these apart. Now, how would that be possible? All right, here we are, Desk Authority. So here it is, the Futaba ML series. That's absolutely the switch we're talking about. It looks a little different the way this looks compared to the white plastic that's on this one. It says for disassembly, the 2 legs are threaded as with the larger Futaba linear switches. To open the switches, first unscrew and remove the 2 legs, then gently insert a screwdriver or a pair or a leg of a pair of tweezers into the retention recess and lever away the clip. The contact leaf should detach cleanly from its mounting lugs. When the sliders you press, unlike the simplified linear, the leaf comes off fairly easily without becoming mangled or torn. Removal of the leaf should not be attempted without good reason, as it is a risky operation. When reassembling the switch, the legs should be placed inside the base and then inserted very slowly, making sure the legs are pressing down to the correct side of the contact leaf. Failure to do so may result in crushed contact leaf that will need straightening, although the reason for the large static prong is unknown. Alrighty, so here are the photos. So I guess we can unscrew these legs. And it does appear that someone until recently was actually selling some replacement switches that were either like new old stock or still manufactured under this KBM-LP. Ah, here's some pictures right here. Okay, threaded legs. Oh, that's kind of cool, actually. That comes out, and then the switch opens up. All right, let's give it a try. All right, so I'm gonna grab this with needle nose pliers. Oh, look at that. It came out. All right, unscrew. Okay, so those are out. And then now it said you get the tweezer under there. And unfortunately, I just sort of bent this little prong right here. That was unintentional. Feels like this switch is sort of glued together. Oh, I just bent my tweezers. Darn it. So this little prong here is sort of bent up now. It does not want to budge at all. It feels like it's sort of glued together or something. I don't want to completely wreck this switch. These 2 prongs on the side, these are strictly for holding into the back plate. They do not latch the white part of the plastic to this black body here. It seems like it's this prong right here, and I've actually kind of stressed it a little bit too much there, trying to bend it. But even if I peel that away, this whole thing does not budge, not even a little bit. To me, it feels like there's a drop of glue inside this little space right there. It looks like it's wet or melted or something like that. That one is the same way. Okay, I'm just gonna slide these legs back in. I think. So you get it into the base there, and then you turn it, and that kind of threads it in. There we go, like that. I'm sure this switch still doesn't work. It's kind of working. It's being unreliable, but I took it from the pile here of unreliable switches, not of dead switches. I did a little bit more Googling, and I found another article talking specifically about these switches. And it says here that when you remove the pins, the ones that I already did take out a second ago, you just have to clean those pins themselves. And I guess the contact is made on those pins. I find that hard to believe. They're saying that you can scrape off the black coating with a scalpel blade and then make sure you clean it with WD-40. Reverse procedure, repeat the other pin, few drops of WD-40 around the plunger on the same side of the key switch, and then improves the action of the key over time. I found this works well with the Master/Elk, that's the Electron, and the BBC Issue 4 type keyboard keys. All right, well, let's start with one of these switches here. That's totally dead. That's with the multimeter there. Let's get these pins out of here. Now there it is, there's the inside of the pin. It's really hard to see. The camera's not really focusing on it, but I suppose it looks potentially a little bit oxidized. So I guess I'll try to clean that. I got some deoxa here on this paper towel. Let's see if that has any effect at all. I mean, it certainly has some junk coming off, so maybe. Well, junk is, I mean, that's generous. It doesn't seem like there's that much coming off. All right, let's get this back into the switch, and then we'll pull out the other one. Okay, there's the other one. I suppose it does look a little bit tarnished. I don't know, it's really hard to tell. What a strange switch design. So there it is, you can see some of this on here. That definitely came off this little peg. So absolutely, I suppose that could be causing these not to work. That doesn't seem that difficult. Interesting. Okay, there it is, switches back together. Let's see if it suddenly has continuity. This one was totally dead. Look at that. It freaking works. Oh, wow. Okay, so I guess I have to go through that with all of these, but that won't be too difficult. Oh, so serviceable switches. All right, I need to not mix these up, and now I'm just gonna go through this entire process. This process took a little bit of time, but once I got the hang of it, it actually wasn't too bad. The one trick to remember is that when you twist the pins out, you have to be very gentle with it because remember this plastic is really old. They come out pretty easily, but when you go to thread them back in, make sure you don't cross thread them. So you kind of have to insert them into the switch until it stops and then give it a little bit of a twist while pushing in. That way it threads back into the switch. You want to turn it until it bottoms out. I found some of the pins were really tarnished. It was very visibly tarnished. And I think that's what the article mentioning a black coating was talking about. That's the tarnish itself. Reinstallation of the switches is quite easy. They just click right into place and then just carefully solder them back onto the PCB. All right, the moment of truth. Let's plug this keyboard back into the machine. Let's see if it actually works. Now, what's funny is it's actually a lot easier to service these switches than I thought. So if any of the other switches start to act up on this machine, especially the ones that I've fixed already, like the enter key, I think it's just tarnished pins inside and I'll just take it out and try to fix it. Okay, here we go. It is the period key. That doesn't work, and nor does the enter key. Come on. So the keys that aren't working: number pad period, number pad enter, number pad 2, number pad 3, number pad comma, and that is it. The rest of these are working. Now what's sort of sketchy is that the non-working keys are this cluster right here. These 5 keys all together. So just because they're all too close together, I'm going to turn the machine off and I'm going to investigate with the multimeter. It seems a little coincidental that all the keys in this cluster right here don't work. And I am seeing that these all do share. They have something in common. They're all connected on the right side here. And yes, indeed, there does appear to be a problem in this area of the keyboard. So this key switch here, I've never actually removed. This is the enter key. If I touch these 2 pins, it's making continuity and it's 0.8 ohms. So that is actually good. But that switch, this switch, and this switch all go to this jumper link right here. And that makes its way to there, which should make its way over to the keyboard connector. Okay, so that shared pin on all those switches that aren't working make its way to this jumper link there, which goes to there, which goes to there, which makes its way to one of these pins on this connector right here. So I'm just going to reflow the solder on these right here, just to make sure everything has a good connection. All right, we're getting under 1 ohm from over there to over here. Sometimes these types of wire connections can be pretty flaky as well. So I'm not saying that this is definitely problematic over here, but it could be. Before I reconnect this keyboard, I'm just going to deoxit these sockets here. All right, let's see what happens. 0, 0, 1, period. Enter. Okay, cool, this works. This did freeze the machine for whatever reason. Some commands freeze the computer where even break doesn't actually get you out of there, like as a reset. All right, let's try that again. 1, 1, 2, 2, 3, 3, period, comma. Yep, okay, cool, this is fixed. All right, so there was a problem. It must have been either the deoxit on the socket here or that reflowing of those solder joints, because this seems to all be working now. Alrighty, well, the keyboard is freaking fixed. All working, at least it is for now. So that's really exciting. I was kind of despondent. I didn't know if I'd ever get this thing working, not without importing a bunch of key switches or something from the UK, but no, these are easy to service. And just watch out for cold solder joints, I guess, or whatever. There's a lot of kind of ugly looking solder on the bottom side of this board. So I touched up a bunch of the other connections as well, but okay, I'm really excited. So at this point, it's now time to put the keycaps back on this thing, and then we can finally type some commands, try to get that CMOS initialized, and actually run some software on this thing, or at least attempt to run some software. And now it's time to reassemble the keyboard. This is always a gratifying process to put all the keycaps on. I like to see the keyboard take shape. Getting the spacebar on was a little bit of a pain, but not too bad in the end. Keep in mind, if you wanted to completely restore this keyboard, every key switch would need to be removed and then the base plate sanded and repainted. That would get rid of that corrosion, but I'm gonna leave it. It's gonna be just fine. All right, finally, we're ready for testing. The keyboard is looking amazing. There's a little bit of wear on some of the keys where it's sort of smoothed out a little bit just from use, but what do you expect? This computer was obviously really well used. I did put 303 aerospace on these keycaps. I really like how it makes the black look much more shiny and pop, much more original looking. And while it's a little bit greasy on your fingers, just for a little while, that'll fade with time, and then the keys will look really good. But yeah, keyboard is looking fantastic. I put the speaker in as well, and it's actually sitting properly in this little holder, so it's not gonna flop around once the case is installed on top. And I think we're ready for power up. That's the normal beep sound that it makes. All right, so the font is a little bit stretched, but I think that's okay because I remember reading on this machine, if you don't have the battery in it, what happens is the CMOS chip, which has the non-volatile RAM in it, it just gets random junk data in it. And that can have strange effects when you first turn on the computer, like the graphics mode being in what you don't expect. It's been always turning on to like what looked like 40 column mode before, and now it's in this sort of, well, looks like a 20 column mode or something. So I remember the trick is you hold down the R key while you turn on the machine, which is gonna reset the CMOS settings. Let's see if that does work. Press break to continue. There we go. We are now in the 80 column mode. Now, I realize what it's trying to do right now. We're not getting a prompt because it's trying to boot a floppy disk. I think hitting Control D and break, there we go, drops us back to the prompt there. So I'm not 100% sure. I think I typed co.file9. Okay, didn't give me an error. co.mode 135, co.lang12, which I think is for basic, and co.no boot, which I think tells it to not try to boot the floppy disk. Now if I hit the Control break key, there we go, we're in freaking basic. And it switched back to what, like a 40 column mode. Wow, okay, print. Let's see if this works. Hello, type mismatch. Maybe that's not the right shortcut for print. Oh yes, there we go. I am completely unfamiliar with the BBC Basic. Oh, this is awesome. Now there is a list of additional commands for, I guess, saving into the CMOS settings, and I don't know if I can type them right here in basic here, but like this one is one of them, no such variable. So I wonder how we get back to that other prompt. Well, it doesn't really matter because there's still no battery in this machine. So as soon as I power it off and I leave it off for several minutes, then yeah, clearly it's not gonna work and it's gonna go back to that original star prompt that we had. But hey, this is the first sign that, you know, this computer is working. Oh, and incidentally, yeah, the number pad is working properly here. Actually, no, the 2 key is not working properly. Oh, the 2 key. Oh, well, it doesn't really matter. I'm not gonna be using the number pad that much. And the fact that, wow, yeah, the 2 key 1 and 3 are fine. And the keys around it, but 2 is just unreliable. Oh, it needed more scraping, I guess, on those little pegs. Oh well, I'm probably gonna leave a note inside the computer to indicate which of the keys that are flaky, so the next time I get up the courage to remove more key switches and do more of that scraping, then I can go ahead and do that. Hopefully all that swapperoo that I did moving those key switches that were working from the number pad over to the main part of the keyboard results in a working keyboard. Results in a working keyboard. Yeah, I mean, that's awesome. Mistake. Hey, I made a mistake. I make lots of mistakes. All right, well, let's get a battery in this thing. I'm obviously not gonna use this. To be honest, I'm not gonna use any AA batteries either. I'm gonna see if I could just use a CR2032 in here for 3 volts, and if that's enough to keep it running. I found that most CMOS batteries in most computers were originally run off 4.5 volts like this, but they work perfectly at 3 volts like a CR2032, and it just may not last as long. So it could be that the chip on here is like a power-hungry IC and would quickly drain a CR2032, hence the need for these large batteries. But until I can find a little battery pack of some type, maybe I can 3D print something that will contain the battery so that if they do leak, they'll just stay leaking inside that little carrier and not inside this machine. First thing I want to do is, we're using the multimeter here. Let's take a look at these pins where the battery connected. Now, people told me that it did try to charge the battery, but that doesn't look like it's trying to charge the battery, like 0.22 volts there. Okay. What I read online says that this outputs 5 volts, like it's trying to charge the battery, a nickel metal hydride or something like that. But that certainly doesn't seem the case. That 0.22 volts is not going to charge anything, and the computer is powered up right now, by the way. Where this comes into play, of course, is if you try to hook up a regular non-rechargeable battery to something that is outputting a current into it, that's just not a good idea. But I don't think outputting 0.22 volts into a 3-volt battery is really going to do much of anything. Maybe unless the battery were totally depleted, then it would be trying to charge it ever so slightly. But yeah, this thing does not appear to be charging anything. I'm still going to cut this battery pack open though and take a look at what they have in here, see if they do have a diode and resistor as people claimed. There it is. I cut open the battery and indeed there is a resistor and a diode in there. So I guess I should reuse these parts on the CR2032 and I don't know, just for safety, I guess. Here's the contraption I came up with. So CR2032 holder, the diode and the resistor that was on the original pack is soldered right on there. So I reused those parts. I actually used a new connector, and that's because the old black wire on the old one, which is this one right here, it had corroded. The entire wire had corroded and I couldn't solder anything onto it. So I went in my parts and I found a new one. Same thing where the middle pin is the positive, just to compare to the original one. There it is. That means you can plug it into this thing either direction. There it is. It's 3 pins. So if you flip it around, it's basically going to be positive center and negative on the outside. And then I ran it to the switch, this switch right here, which I just need to tighten down. And that allows me to turn the battery off and on because I'm not sure how long this CR2032 will last. That way I can just flip this into the down position to turn it off when I'm not using the computer for extended period. And then I just have to retype in those setup commands when I turn the machine on. So it's in the up position there. I gotta tighten that nut. It's in the up position. Let's connect this up to the battery connector on the computer. Alrighty, so we're back to this is not a language. So remember, I gotta hold down R while we turn the computer on, and that will do a CMOS reset. So here we go. Let's see. Press reset to continue, or break to continue, I mean. All right, so Control D break should drop us to the start prompt. And now I'm going to type in all these commands, which should set up the CMOS memory. I typed in all those commands. A couple of them I typed in incorrectly, and it's funny because I'm not used to the fact that the delete key is down here next to the shift key, and the back arrow seems to be like an insert mode. Let's see, if I type some stuff in here and I push that, and when I type new stuff, I don't know, I don't understand what's going on there. That seems a little unusual to me. And then pushing the delete deletes that character and leaves the cursor where it was. So not quite sure how the editor works, but I think I typed in everything correctly. I'm going to power cycle the computer and let's see if it retained those settings. Well, I guess I need to power it off and leave it off for a few minutes, then I'll turn it back on and we'll see if those settings saved. All right, it's been around 5 minutes. Let's turn the computer back on. It looks like it worked. I think it's resynchronizing the video. Yes, we're still in basic. Awesome. So the prompts we're seeing are Acorn MOS, which is machine operating system, Acorn 1770 DFS, which is disk file system, and it is 1770 is the disk controller chip that's in here. It's I think it's like a Western Digital 1770 or compatible chip, and then basic. I think there's also ADFS, Advanced Disk File System, that's also in ROM on this particular computer. Now, there are some commands I think we can type. Asterisk info? No. Asterisk configure. As far as I'm aware, this configure command allows you from basic to configure some of the CMOS settings. So if we do configure and we do quiet, I think that makes the volume quieter. So now if we turn the computer off and on, I think the initial beep shouldn't be as loud. Okay, well, so what happens with the sound chip on this thing is when you first turn it on, that loud screechy noise is just random values in the sound chip producing those tones. And what the ROM needs to do on the computer is then take control of the sound chip, initialize the registers, and silence the speaker. Control G makes a beep sound and it's really quiet. I'm gonna type in configure loud. If we hit break, oh, there it is, louder now. So that does work. Okay, cool. Configure quiet. And we hit control break. Now it's quiet. I think we could do star help. And so this tells us about the ROMs that are in here. So we're running OS 3.2, terminal 1.20, view, whatever that is, B.3, and then SRAM 1.04, whatever that is. And then it's frozen. There's no more I can do. Break will exit out of that though. So this machine has 2 cartridge slots, and I did see online that there are PCBs available that you can install ROMs into, so you can stick those in this cartridge slot. We also have 2 empty ROM sockets here, plus an EEPROM, which may or may not be something that's originally from this machine, but there's no sticker on it. And then there's this ROM here, mask ROM, which certainly is the original one. So I'm wondering if this EEPROM has additional software on it, where BBC people will be able to look at this list here and know if any of these are different versions or don't belong, like they're something that was added onto this machine. Now I'm wondering if I can type like star and edit, for instance. Does that go to an editor? Yes, look at that. It goes to some kind of an editor. This is like a word processor. Wow, that's kind of cool. It's built into the ROM, but I mean, remember this machine came out in '86. ROM space was a lot more readily available than it was in the early days of the first BBC. Well, we appear to be to a point where this computer is ready for me to play around. So far, I've just sort of been like poking around in the dark with these commands. I'm gonna put this computer together the rest of the way, and then I'm gonna start taking a look at the getting started guide to figure out a little bit about how to use the machine. Because right now, all those commands like star, stuff like that, it's pretty foreign to me. So I need to kind of get my head wrapped around that stuff and then maybe figure out how to load some software on this thing. Alrighty, the Master 128 is reassembled. It's powered up. It's been working great because it's been a couple days. The battery is working. It's retaining the settings as well. And just look at how nice this all looks now. The 303 protectant on the keycaps makes everything look brand new, and I even put some on the surround here as well, and it looks absolutely amazing. In fact, the entire computer, other than the slight yellowing, just looks amazing. Now you notice I have a disk drive hooked up here, and I do. It's just a normal 3.5-inch disk drive. It's connected to the floppy drive interface on the bottom side of the computer. The drive is set to drive select 0 or DF0. This is a high density drive, but I'm pretty sure this computer, of course, only supports double density disks. And the machine is connected to this composite Philips monitor here, which incidentally supports NTSC and PAL frequencies without any issue. And 80 column text looks fantastic on this machine. The text is incredibly sharp. It's very, very readable, and you can easily switch between the different modes by typing like mode 0 or mode 1. Now we're in a 40 column text mode. And I did save it to boot up into mode 0 in the CMOS settings, so control break automatically goes back to 80 columns. Now I went ahead and made a floppy disk for BBC Master Welcome Disk. I found this disk image online, and I found a DOS program on my PC to write this disk. Now, I haven't actually tried booting it. I don't even know how to boot a disk. I'm gonna try typing star DFS, see what happens. the light's on. Ah, it says disk fault. Okay, well, maybe I need to do ADFS, which is the other file system. All right, the disk light came on again, and it didn't do anything. So is that a good sign? Maybe? Okay, there we go. It's working. Look at that, it's freaking working. So what I did is I held down A and break. This was after the system was turned on, and it seemed to try booting up the system again in ADFS. This disk must be an ADFS floppy disk. This is the one that must have come with the computer originally. But take a look at that, this thing is running some software. So cool. Now that it's booted up, I'm trying to see how I can exit out of this. Spacebar, enter, escape. None of the F keys seem to do anything. What is this supposed to be doing? Break? Okay, well, we have a flashing cursor, but now what? Hello? I'm sure the manual for this thing probably gave some instructions on how to use this disk a little bit better than I'm doing right here. Well, I think I'm gonna end this video here. I got the computer loading some actual software, so that's kind of exciting, but I still have no idea of what to do with this computer after this. So I'm really looking for some insight from the BBC experts out there who can give me some tips and tricks on what software I can run on this thing. Is it worth running stuff off floppy disks, or should I try finding ROMs or tape images? This is all stuff I'm not sure about. We also have more to do. I want to do a mod to this thing to get composite color video out of this thing, because like I said, right now it's only monochrome. Also, we have the RGB output, which of course is going to be much better quality, so I'd like to test that out. And then I have that US domestic market Acorn RGB monitor, which will be a perfect companion to this thing, hooked up through the TTL RGB output of this computer. When it comes to the keyboard restoration I did on this computer, I was actually dreading the entire process when I first started it, just because recently I've done some work on like the Apple II Datanetics keyboard, and that thing is such a pain in the butt. But this keyboard actually turned out to be pretty good and pretty easy to service. Once I got the hang of it and figured out the little details, I'm not scared of having to fix more key switches in this computer going forward. And I am really pleased with how this turned out, both cosmetically and the keyboard itself. So thank you very much, George, for sending this in all the way from the UK. And hopefully I'll get some good tips and tricks, and I think I'll bust out the starter guide manuals or whatever came with this thing so I can try to figure out how this thing works at least, because at least this welcome disk works. I can play around with this a little bit. So if you enjoyed this video, I'd appreciate a thumbs up. And if you didn't, you know what to do. Hit that subscribe button if you haven't already. Comment down below. Huge thanks to my patrons. They support me, and that means so much to me. Their names are scrolling up the side of the screen. If you want to support me, you can do so with the link in the description below. And yeah, I mean, that's going to be it really. So thanks very much for watching. Stay healthy, stay safe, and I will see you next time. Bye.